Next slide, please. Okay, before we get started here and talk about Alchemity, I'd like you all to take a look at the 6 product icons on your screen. If I asked each of you what would lower the cost of these goods, you'd probably say software or chip for the computer and phone, or electronics for your grill settings and refrigerator, or maybe lighter and stronger materials for your car, or a new chemical composition for your nasal spray. And that all might be true. But I'm here with Alchemity today to tell you about an innovation that's going to revolutionize the basis for production of all of these very distinct goods and services that on the surface don't seem to have much in common, and how our technology will lower the cost of goods sold in an environmentally friendlier way while doing it. Next slide, please. And this innovation relates to something called natural gas liquids, without which we wouldn't have our plastics for our phone and computer, or propane for our grills. We wouldn't have refrigerant in our refrigerators to keep our food cool, or our nasal spray. I'm here today and I'm going to start by teaching you a little bit about natural gas liquids because they're kind of complicated. And then we're going to show you how together we can upend the 95-year-old incumbent process and production model for what is a $60 billion industry through our company, Alchemity, which we aim to fundamentally reshape the energy industry with a novel technology application that offers a simpler, faster, cheaper, and distributable gas to liquids chemical conversion process without producing emissions. Very quickly for an overview, you might recognize some of the names of the liquids at the top here: ethane, propane, butane. Those are all the forms of natural gas liquids that are used as a base to create the plastics and medicines and cleaning supplies and even the gasoline for our cars. And they're very much the building blocks that we enjoy, all the things in our lives and that drive our economy. And they're produced in 2 ways. The first is as a naturally occurring byproduct of oil and gas drilling, which is kind of what you see up there on the left. And secondly, they can also be produced directly from gas in a handful of mega scale, multi-billion-dollar plants, which are very limited. There are only 4 industrial size in the world, and they're all in Qatar, Nigeria, and Malaysia. To give you a sense of what gas liquids technology costs today, the most recently commissioned plant construction was $19 billion. It took 500 million man hours to build, and it sits on a plot of land half the size of Central Park in New York City. And it's only at that scale that the existing and current technology for gas to liquids conversion allows for an investment business case. Next slide, please. All right. And so with that, we've identified many problems as part of our natural gas liquids industry. But the big problem that we believe that we can address most quickly is around an underdeveloped, inefficient, and costly supply chain that increases consumer costs and their carbon footprint. This map is obviously a map of the United States. The US produces 22% of all the gas in the world. We're the #1 gas producer, and we produce more natural gas liquids through our drilling processes than any other country on earth. And we don't have any gas to liquids processing. And the reason for that is we don't have enough infrastructure in this country coming from these primary gas fields in North Dakota, Pennsylvania, or out west. And actually, in order to move those products, they have to come through just a few distinct pipelines, and they primarily end up in Conway, Kansas, or outside of Houston, where they're stored in these big, huge salt caverns. And then in order to get back out to their customers, not exclusively transported this way, because there are some pipelines in the Midwest and a few in portions of the East, but essentially all that product has to be moved from those hubs to the West Coast, where there's no other transport methodology than rail and trucking. And the same thing's true of trying to get any product into the Northeast or down into Florida. We're captive to these 2 major natural gas hubs. And that's, again, because we require primarily salt caverns, which are located in geographically limited areas in order to actually hold all of this product before it gets to market. So just give an example of the efficiency, in order for it to get propane to get to Los Angeles for your grill, it could be produced in North Dakota, sent to Texas for treatment and storage, then put on that rail car and railed out to California, where it would be stored somewhere above ground, and then it would be trucked out to the consumers. And yet there are actually natural gas producing fields 3 hours east of Los Angeles that can't participate in that market. So it's pretty simple. The longer and more efficient the transportation to market, the greater the cost for buyers and consumers who have to pay tolling fees, have different and strict regulatory requirements for rail cars and trucks, have to deal in arbitrage for storage. And if there was a technology that could help those customers avoid paying the fees for pipeline transportation and liquid separation along the way in Kansas or in Texas, those fees that are built into existing contracts, then our US natural gas customers could have avoided $7.6 billion in fees last year, simply because we have a captive market and not a lot of ways to move it. Next slide, please. Okay, and this is where Alchemity comes in. Our Alchemity solution, which we'll talk to in just a second, is going to open the door for distributed, what we're calling micro gas to liquid systems. You can see here, there are no pipelines. You have Alchemity products scattered around the United States, close to some of the producing natural gas fields, that obviously will be able to bring that product to market in a much more efficient manner than exists today. You know, it's going to open that door to small-scale distributed gas liquids deployment. It's going to eliminate the need to remain captive to large-scale capital investments and costs associated with natural gas infrastructure. You can think of it a lot like a farm-to-table movement for food, but applied, in this case, for all the feedstock for production of all the goods and services that we enjoy. We will reduce trucking miles, prevent the need for land getting torn up for pipeline inlays, and the safety risks and costs of long-distance rail transport. Next slide, please. Okay, and here's the Alchemity solution. Our genius scientists on the Alchemity team have been working in labs, and they have created a one-step membrane reactor. And you don't have to be a scientist to make sense of this. The picture on the right shows a conventional gas-liquid process that those huge plants that are overseas are using today to produce liquids from gas. And Alchemity essentially takes these three big events and all the associated equipment and investment that goes into actually making that possible, and it creates a reactor that can combine all of that activity into one step, and all the associated costs go away. And it truly is a solution where gas comes into a membrane reactor and out go those liquids. There are four kind of key parts and added value opportunities here. It's an intensified process. This opens the door for smaller, cleaner, more energy efficient gas liquids production. It reduces costs by opening the market to natural gas liquid contracts without having to pay all those midstream fees for transport and storage. It has an application for carbon capture and use, which is an environmental application where we can use it to convert waste gas into new revenue. And if we're able to do that in our midstream and upstream portions of the energy sector here in the United States, we could reduce the US gas emissions by 33%. And it also opens the door for flexible product mix. You can change the output, meaning the types of liquids that it produced, very simply with a catalyst selection and sweep gas, and it can offer far more product mix than any other small gas to liquids technology which is being worked today. Just as a side note, we do have, we're very early stage, still barely coming out of the lab, but there is intellectual property and patents associated with the technology. 3 patents been issued, 3 are in process. So we're working to control that and make sure that it works for us. Next slide, please. So who are our customer segments be? Well, this is the exciting thing. We think that we can service all 3 primary segments of the energy industry, from the midstream US natural gas processing facilities who flare gas, and we believe we could have a micro GTL unit that would be part of their gas flaring systems. We could capture it instead of burning it off into the environment, converting it to a liquid, which then they could sell right back into their existing infrastructure. Same thing with US oil and gas drilling. We envision moving these around wellheads, capturing that gas, turning it into products, and again, avoiding that flaring activity, which is causing environmental harm. And the really big opportunity comes from what we showed on that map. The opportunity to develop and scale small-scale gas liquid plants distributed around the United States, closer to gas plays, and being able to bring that product to market by cutting out the middleman. Next slide, please. And so as far as that goes, we also need, as part of our process, we've identified a key stakeholder landscape. Because we're brand new and looking to accelerate, we know that we're going to need potential strategic partners, and we would see some of those integrated energy giants that are in the gas liquids plants in business today, like Shell and Chevron, who not only have been working at research and development in the field for 40 years, but they also have access to the midstream, downstream, and upstream spaces. And they would be a great brand to bring alongside with us. Same thing on our customers. We've already identified that midstream companies who are in the natural gas liquids processing business today, we think they would actually benefit. We don't view ourselves as really competitors to them. We view us as an augmentation. And last bit would be the customers. There are some other companies that are doing small scale gas liquids plant development. None of them have been successful year to date because they're using incumbent technology scaled down to a small size, which has already been proven by the market to not be productive in any way and actually not make any sense economically. The most recent plant that was developed in a small scale in Oklahoma was commissioned in 2017, and by 2018 it had failed because it was just too expensive. As part of our customer discovery process, it's worth noting this quote here that a gentleman who works at Shell and the gas liquids business, when presented with the Alchemity solution, it stated that this is something every chemical company has been working at for years, and this may be the code that everyone's tried to crack. Next slide. All right, our business model is pretty quick, pretty easy. We're just going to sell microreactors and charge a commission on some service fees. We estimate that a cost for these micro units, we'd sell them at about $143,000. They cost about $85,000 to make. So we're looking for a gross margin of about 40%, but we think that's fair because the return on investment for any customer is a little over 1.5 years, and we think that's a very competitive amount of time and offers a high value proposition for anyone. Next slide, please. Okay, and this is our financial model. Based on a relatively conservative estimate of how many units we believe could be sold, we think that by 2030, 9 years from now, we could be deploying about 140 units a year for about 600 in the market, and we'd be bringing in revenues or EBITDA numbers of a little bit under $8 million a year. And we don't think it'll take us too long to get to market. There's some research and development work that has to get done, and we think we could be selling and deploying by year 2, year 3. Next slide, please. And this is last bit here, our team. You've got me, Mike Peterson. I've got 10 years in the oil and gas industry. I've been working at Shell for almost 11 years now, so I have some experience in the upstream space as well as in corporate affairs. I also had spent a year in a startup in Germany. We've got Greg Cooper, a founder and former CTO of an advanced materials company in Maryland. He's also done quite a bit of startup business consulting and brings a breadth of experience from the startup side. And of course, the two people who made this possible, the scientists that have actually invented the technology. We have Dongjia Liu, who's been working in research around in this particular subject area for over 9 years at University of Maryland and done some fellowships up in Rochester. And of course, Eric Waxman, who many of you probably know. He's a seasoned inventor and very active in the energy innovation space. He's founded a couple companies. He's currently the founder and executive chair of a VC-backed battery storage company and brings a lot to the table for us. And that leads us to our last bit, our ask. And our ask, we really need about $2.5 million in order to get this going. We've just submitted a grant to the Department of Energy that aligns with our technology application for $2 million. We're at a TRL 3 level, so still early stage, and we're going to need that to refine the technology and begin thinking ahead to prototyping and product development. But from a private sector ask, we're going to be looking for $500,000, and that's really just to get us up, started, and running, to cover our legal fees for company setup, our IP patent landscape review, and there are some exclusive licensing agreements we'd have to sign, as well as just general business development. And with that, I will thank you all for your time.
Great, thank you very much, Mike. And I'm going to turn it over to Curtis for questions.
Thanks, Mike. That was a great presentation. You talked about some of the traditional technologies or how some other competitors have tried to do this in the past. Could you maybe just talk briefly about some of the challenges they faced and why you think you can overcome some of those challenges?
Definitely. I think it's pretty simple, and thanks for asking. You know, essentially there are about 10 companies worldwide that have been trying to do this small scale gas to liquids processing for just the reasons we've named. Very inefficient supply chain, it's not distributed at all, but it's an important part of the energy market. And the reason that they haven't been successful is, you know, there's still quite a high capital investment, even if you're trying to scale down one of these plants. So the average cost of the deployed gas liquids plants have been about $250 million for plant build and development. And essentially what they're using is they're using that existing technology that those big companies like Shell or Sasol and Chevron are doing overseas. And they've really, it's a process called Fischer-Tropsch, which is those kind of 3 big steps that we showed in sequence. And they've really just worked hard in their own ways to try to scale it down to a smaller size. And it's just not proving successful. The costs compared to, especially, you know, when natural gas liquids they're traded in commodities markets, the price fluctuates quite a bit. You know, 8 years ago, it was $15 a barrel. Today, it's $3.60. So there's a lot of economics that go along with it. But we think that our technology, by really simplifying that process, by breaking down those steps, is going to just, that's really the key to all of this and making gas liquids at a smaller scale a reality. It's never going to work with the existing technology applications. No matter how hard and well-intended all these other small scale developers have tried. And we think that's really the value add of this Alchemity reactor, which really does it all in almost one fell swoop.
Can I add to that also? Because I also want to explain the environmental benefit of it. The existing technology is an oxidation process. So they do what they do, they form syngas. They oxidize the methane to CO and hydrogen, and then it goes through Fischer-Tropsch and everything else. They have to have a complete air separation plant just to start, and that just doesn't scale down. Our process is not oxidative. It, in fact, is a non-oxidative process, which is shown here. And because of that, we actually don't form any CO2. So the impact on climate is immense. I mean, this is your gigaton type of impact on CO2 emissions, because you just removed all of the oxidation to CO2 in these plants. Instead, we take a hydrogen away from the methane. That hydrogen goes through the membrane, and it's oxidized by the air, which is free, to form water. The only byproduct is water, and that provides all the heat and energy necessary to operate the reactor. So we're talking gigaton reduction in CO2 emissions in the US alone using this type of technology.
Thanks, Eric. Thanks, Mike.
Yep.
Claire?
Yeah, and great presentation, Mike. You did a really nice job. My question has to do not with the technology, but rather how much money are you going to need between now and I think you said 2030, when you anticipated making $8 million of revenue, as a first part of that question. And the second part of that question is, who do you think is going to buy this product first to get you that $8 million of revenue in a year?
Yeah, it's a good question. I mean, so we have to do a bit more economic analysis, and it's obviously a lot of conjecture at this point, right? This is essentially a brand new.
It's early stage. That's
early stage.
Yeah.
You know, we think, you know, we certainly think, you know, part of that $500,000 ask at the beginning, we think that can get us a couple years. We've just spoken to lawyers about what it's going to, you know, our biggest concern really was around IP protection and kind of just the fundamentals of starting a business. We just got that number today from the law firm, and I find it very reasonable, and I think the $500,000 will probably carry us a couple of years until we can actually start getting more revenue. So, you know, it's a good question. I probably don't have a good answer for you today. I need to do a little bit more research to try to figure out, you know, what we really need to carry us forward. But you know, the big thing for us at the moment is really getting that money for technology development, which obviously we know is the challenge with clean tech development in general. It's, you know, that's the big piece here, because there's certainly some refinement that needs to be done and some improvements on efficiency, and we have to show it at a scale too. It's, you know, in a lab right now, it's proven at a, you know, with a very small, very tiny, thin membrane, but the science is, you know, is proven effective. The second part of your question, who we're going to sell to. I mean, this is the exciting part of this, right? We're talking right now about micro GTL reactors, which really can produce only about 4,000 barrels of these natural gas liquids a year. And that's not a lot of natural gas liquid, right? That being said, we see an opportunity to deploy it in the upstream space, meaning the oil and gas drilling areas. We estimated that you would need around 1,600 of these units, micro GTL units, deployed in the producing fields in the United States, this is largely North Dakota, Pennsylvania, Ohio, and West Texas, New Mexico. We think with 1,600 attached to these wellheads as part of a well development period. For example, these wells flare for about 2 weeks after the initial drilling of a well occurs, and then they're usually all capped. But we see an opportunity to kind of, with 1,600, you could pretty much move these, and because they're small, they can be mobile around the United States. And the US basically accounts for about 20% of the global wells drilled in a year. So there's, you know, and again, you'd have to replenish these over time, but that would be part of the upstream space. As far as the midstream, the natural gas liquid processing plants, there are 510 of those in the United States right now. Each one of those also flares its own gas, so we believe that we could help them capture some of that waste product as part of their just general operations, convert it to a liquid. And the beautiful thing about that, and this is why we view them as a smart first customer segment, is because they have existing natural gas liquid technology right where they're at. They're controlling the pipelines. They're separating that liquid or gas that's coming down in from the oil and gas fields. And we think this would be a really great augmentation for them, and also could just be a new type of business operation. They have the perfect gas that's clean and dry, ready for conversion. So you could see an opportunity for them maybe to say, hey, you know, we might want to get into this business ourselves. Microreactors would certainly work, but there could be an opportunity for a larger scale unit as well. And that's the beautiful thing about this technology. We are not just talking about, you know, our vision is about a refrigerator-sized unit near a wellhead or anywhere where there's flaring going on that would produce about 4,000 barrels a year. Of course, you need storage tanks on site and all the ancillary pieces of it. But the other side of it is we're not limited to just a micro size. With this technology and the number of steps that it's reduced, which reduces a huge amount of the capital requirements. We think this offers a brand new opportunity for any customer size that would be necessary. And this could be scaled all the way up to that, potentially that mega scale for a company like Shell or Chevron. So we see real versatility with the design opportunities and possibilities.
Yep.
Michael?
Hey, Michael, this is Michael. Nice job. Thanks for the overview. My question is, if a unit is situated basically anywhere upstream of a refinery, there's sort of limited control over gas composition that you have. And so my question would be, what cleanup needs to happen on the front end before it enters one of these units? And same on the back end, what about post-processing needs?
So that's a great question, and it's not something we should shy away from. In order for this to work and for this equipment to be durable, you do need clean gas. So your point is well taken. This is a standalone reactor as now, but there's no question that upstream of this unit, we would need to have some sort of gas cleaning process. Now that equipment exists, but it also suggests an opportunity for a partnership for companies that are in gas cleaning and gas processing. We actually spoke to a company in Maryland that's in a biogas industry. They do this, they actually clean methane, produce methane from poultry waste. And they had talked about how they do that right on site near these big anaerobic digestion tanks. And then they clean that gas and inject it straight into the grid. And when I brought this concept to them, they said, all right, that would be, the companies that we partner with for gas cleaning, that would be a natural partner for you. And for a relatively small size unit, we think that would be an opportunity. But there's no question that's another piece of the equation to solve, making sure that, especially if we're out in field deployment, we're going to need to have not just the reactor, but we would need a gas cleaning equipment to work with it as well.
Okay,